Hello and Assalamualaikum. We are from Group 12 are going to present about pasteurization process. These are the group members for the Group 12. For the introduction, in the industry, pasteurization is a process that the raw milk goes through. This is due to the fact that unpasteurized milk, especially when maintained at a temperature either below or at room temperature, is a favorable environment that supports enormous multitude of hazardous microbes. The hazardous pathogenic organism in milk must therefore be destroyed through heat treatment before further preservation. Because of this, controlling milk temperature is essential to the dairy industry in order to avoid contamination and damage to the milk's quality, including loss of color, flavor, fat, protein, and other valuable components. Milk is pasteurized by being heated to a predetermined minimum temperature for a predetermined minimum amount of time. Increasing positive contribution to the unfolding entropy can be accomplished by raising the temperature. Heat transport hold a central place in food engineering. From this vantage point, plate heat exchanger, turbulent exchanger, spiral flow exchanger, shell and tube exchanger, and scrap surface exchanger. Basic function is to transport heat to a fluid or between two fluids based on thermal specification. For the objective of this project, to model a pasteurization process in industry, to stimulate real application by using computer-aided software to analyze the effect of disturbance on the pasteurization process.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Nazarul Afwan. I will continue this presentation with literature review. There are 12 studies that we came across for this literature review from the processing food quality optimization and process assessment books by Oliveira published in 2019 said that pasteurization is a comparatively gentle kind of heat treatment. It is to inactive enzyme and eliminate spoilage vegetative microorganisms such as bacteria, yeast, and mold found in low acid food at pH 4.6. This pasteurization process requires heat to eliminate the germ. It can be proved from the journal Heat Consumption and Quality of Milk Pasteurization by Kazimirova that published in 2013. It said temperature of milk and water are monitored at location easily accessible by the design of the pasteurizer. The pasteurizer in conjunction with machine control and automation accomplish the required heating and cooling capacity for the manufacturing of high quality milk and dairy product. Next, there are five methods to pasteurize the milk from the previous research. The method are low temperature long time pasteurization, high temperature short time pasteurization, flash pasteurization, high temperature short time pasteurization, and ultra high temperature pasteurization. This method widely from milk pasteurization and equipment books that written by Dohtre in 2019. Also, it from the research. It from the website How Does Flash Pasteurization Work by Blaylock in 2019, and also it from the advanced micro level experimental technique for food drying and process application books by Karim Fauzia and Rahman in 2022. Lastly, this method also from the research of automated control of high temperature short time pasteurization food control by Negis, Sina, Shashliza, Romanaukas, Armstrong, and Stroud.
For theoretical calculation and analytical procedure, these are the figure for hot water circulation loop. These are the equations that were involved, which is equation 1 where heat loss QA as a result of heat exchange that took place in the heat exchanger, where CW is specific heat capacity of water, FB is mass flow of hot water, TB is temperature of hot water in the loop, and TBC is temperature of hot water returning from the heat exchanger. Equation 2 show that the heat gain QB by the environment of heat loss by the system to the environment where Ti is room temperature, H is heat exchange constant which is measured in Wm square per K, and A is area of hot water loop. Heat transfer by the steam line to hot water circulation loop QO which depend on the thermal power PT of the steam applied which range between 0 and 1600 watt. Because if that the actual transfer heat QC equation was developed in equation number 3. According to the first law of thermodynamics, the algebraic sum of all heat transfer is equal to 0. Considering from the figure, the arrow direction of heat transfer which invariably imply that only QO was positive while other the indicated negative to the system. Therefore, equation 4 was developed. Assume QO equal to PT to be the thermal power as a result of the steam supply to the plant QA and QB respectively. For equation 5, FB which is the hot water flow rate depend on the speed of hot water pump and B. Therefore, QA can be expressed based on equation number 6 and 7 where K and B CW equal to KA and HA equal to KB.
Assalamualaikum, my name is Nurul Jabitairi. My matrix number is AD10038. I will be continuing with the PID controller. So the PID controller performance is determined by three parameters, which is KP, KI, and KD. As a result, it is critical to optimize these parameters. The transfer function of the system model equation is required for the PID controller design for the plant. Nevertheless, in order to decide the transfer function, an expression for output per input must be achieved from the model equation. As a result, the required temperature is achieved caused by heat supplied by thermal energy over a given time, depending on the specified variable for the pasteurization process. Hence, pasteurization temperature is being used as an output and thermal power is being used as an input. Next, as can be seen here is the transfer function for our project, and it is being like this. As we can recall that CH is equal to 21.04, K is equal to 0.36, and KB is equal to 1.21. So in this project, we are focusing on controlling milk pasteurization temperature (TP) that need to be set higher than 75 degrees Celsius. As a result, TP was set to 85 degrees Celsius, and the model obtained for TB was adopted based on the observation from the plant operation that TB approximately equals TP equals to TB. The ZN Ziegler-Nichols tuning method is applied for these tuning PID controllers experimentally. So next is the Simulink block diagram for the PID temperature control for pasteurization process. That's all from me. Thank you.
Results and discussion. In the MATLAB or Simulink environment, simulations were run to assess the effectiveness and performance of the control method for the predicted pasteurization temperature. Figures X to X show the outcomes of the pasteurization temperature simulation. Input temperature is Tp equal to 80 Celsius and a sample period of 5 seconds were utilized in the simulation to get the results for ZNPID temperature control of the pasteurization process shown in figure 8. Figure 9's line graph was found to have an overshoot of negative 1.322% and a climb time of 4.242 seconds. The graph demonstrated how successfully the NPID maintains the target temperature. This is our picture of the result. That's all.
Conclusion and recommendation. Overall, it can be considered that the project's goals have been met. We have demonstrated via the completion of this project our capacity to analyze the stability, steady state errors, and transient response of control system. Following that, we can show how to analyze and develop physical system utilizing time and frequency response technique for actual use in control system. After that, the block reduction approach is used to determine the system transfer function. Additionally, using the MATLAB Simulink software, We can put the problem-solving techniques into practice and validate the ideas learned in basic control system. In recommendation, there are some recommendations that can be made from this project. Try using other tuning methods such as Chin-Horn-Reswick and Cohen-Kuhn tuning methods. Compare each tuning technique to see which has the better result.